Nenomatica, where mathematics meets YouTube excellence. In this lesson, we will master how to multiply radicals with different indices and prove the rules step by step, then finish with a clean example. Suppose we want to multiply an mth root of a by an nth root of b. Here is the product we want to simplify. The big idea is to convert both radicals to share the same index. We will build a common index equal to m times n. Here is the theorem. The mth root of a times the nth root of b equals the m nth root of a to the n times b to the m, assuming a and b are non-negative. Proof. We rewrite each radical using fractional exponents. That gives a to the 1 over m times b to the 1 over n. Next, give both exponents a common denominator mn. So a to the n over m, n times b to the m over mn. A power with denominator mn is an mnth root. So this equals the mnth root of a to the n times the mnth root of b to the m. Finally, multiply under a single radical. We obtain the mnth root of a to the n times b to the m, QED. Example, multiply the square root of 5 by the cube root of 4. We convert both to a common index of 6 because 2 times 3 equals 6. That gives the 6th root of 5 cubed times the 6th root of 4 squared. Now combine under one radical. We get the 6th root of 125 times 16, which is the 6th root of 2000. Visually, think of each radical as a box labeled by its index. We stretch both boxes until their labels match, then merge them into a single box. 2 notes. 1. Using a common index mn is the most direct path to multiply radicals with different indices. 2. If either a or b is negative, pull the negative sign out of the radical first, then apply the rule carefully with domain restrictions. Summary. Step 1. Rewrite as fractional exponents. Step 2. Use a common denominator mn. Step 3. Translate back to mnth roots. Step 4. Combine under one radical. The final rule is the mth root of a times the nth root of b equals the mnth root of a to the n times b to the m. Problem statement in bold orange. Square root of 2 times cube root of 3. Rule box. Product of radicals with different indices says mth root of a times nth root of b equals mnth root of a to the n times b to the m. Apply the rule to rewrite the expression with a common 6th root. Now, write the product inside as 72 under the 6th root. Example, problem statement in bold orange. 5th root of 3 to the 4th times 7th root of 2 to the 3rd. Show the same rule box again. Apply the rule to get a 35th root with exponents outside the parentheses. Finally, simplify the powers to 3 to the 28 and 2 to the 15 under the 35th root. Now, we recall the multiplication rule for radicals with different indices. In our solution structure, we next switch to a common index using the least common multiple of 6 and 8, which is 24, then raise each base accordingly. Now combine the factors inside the same radical. In tuition, we rewrote each radical with the shared index 24. 4 copies of 1/6 make 1 whole, and 3 copies of 1/8 make 1 whole. So raising the base to the 4th and 3rd powers matches the indices perfectly. Example, Part B. Start by writing the expression as given. We first factor out the negative sign from the cube root. Now bring both radicals to a common index using the least common multiple of 3 and 2, which is 6. Next, apply the rule and rewrite each factor under the 6th root. Finally, multiply inside the radical. Write the original expression. Because we have an odd index, the cube root of a negative can be pulled out as a negative sign. Multiply the outside numbers -5 and 2 to get -10. Next, convert each radical to an equivalent form with a common index of 6. Now that the indices match, combine into a single 6th root. Add the exponents inside the radical. Finally, rewrite 2 to the 5th as 32 for a clean final form. Therefore, the simplified form of problem A is -10 times the 6th root of 32. Problem B. Simplify the product of the cube root of 4 and the square root of 2. Start with the original expression. Use the common index idea again, this time using 6 as the least common multiple of 2 and 3. Now combine them into a single sixth root. Replace 4 squared by 2 to the fourth. Combine the powers of 2. Factor out 2 to the sixth from inside the sixth root. Take the sixth root of 2 to the sixth to bring out a factor of 2 and finish. So the simplified form of problem B is 2 times the sixth root of 2. Example, we will simplify the product fifth root of 8 times cube root of 4 times square root of 2. Step 1. To multiply radicals with different indices, raise each radicand so the indices match a common index. We choose the least common multiple, 30. Show the product rule. Applying it gives fifth root of 8 to the sixth power times cube root of 4 to the 10th power times square root of 2 to the 15th power. Step 2. Combine the product into one radical with index 30. Step 3. Rewrite 8 as 2 to the third and 4 as 2 squared. Then simplify exponents. Step 4. Add the exponents inside the radical. Step 5. Split the exponent 53 as 30 plus 23. Step 6. Use the property nth root of a to the n equals a, so the 30th root of 2 to the 30 is 2. The final simplified form is 2 times the 30th root of 2 to the 23rd. Second example. We will simplify square root of 15 divided by cube root of 5. Step 7. Harmonize indices. The least common multiple of 2 and 3 is 6. So write each as a sixth root using the product rule. Show the rule. Step 8. Rewrite the division with a single sixth root of the quotient. Step 9. Factor 15 as 3 times 5. Then expand and simplify by subtracting exponents on the 5s. Step 10. Evaluate 3 cubed equals 27. So the final answer is the sixth root of 135. Summary. We matched indices using the least common multiple combined. Here is our example. First, the fourth root of 225 divided by the square root of 25. Second, cube root of a square divided by seventh root of a cubed, all over the 21st root of a to the 12th. Rule. When radicals have different indices, we can rewrite to a common index. For example, the square root of b equals the fourth root of b squared. Then division of same index radicals can be combined inside one radical. Convert the square root of 25 into a fourth root. Then combine the division into one fourth root. Now factor 225 as 5 squared times 3 squared. Then reduce powers of 5. Recognize that this is a square inside a fourth root. The fourth root of u squared equals the square root of u. So we get the square root of 3/5. That completes the first expression. Now for the second one, we closely follow the same algorithm, but with a common index of 21. Rule. To compare or combine radicals with indices 3 and 7, rewrite each as a 21st root by raising the radicand to a matching power. Rewrite cube root of a squared as a 21st root of a to the 14, and seventh root of a cubed as a 21st root of a to the 9. Keep the denominator as the 21st root of a to the 12. Combine the division inside one 21st root. Simplify a to the 14 divided by a to the 9 to get a to the 5, then divide by a to the 12. Write a to the negative 7 as 1 over a to the 7. Recognize the seventh power inside the 21st root. And simplify to the cube root of 1 over a. That equals 1 over the cube root of a. First, write the expression. Rule. Convert the cube root to a sixth root by squaring its radicand. Now both are sixth roots, so we can combine them into a single sixth root. Expand the squared binomial, 2 minus root 3, quantity squared. Replace 4 plus 3 minus 4 root 3 with 7 minus 4 root 3, and multiply by 7 plus 4 root 3. That's a conjugate pair. Use the difference of squares. 7 squared minus the square of 4 root 3. Compute to get 49 minus 48 equals 1, and the sixth root of 1 equals 1. Now simplify. The fifth root of the product of the cube root of 2 and the cube root of 4 multiplied by the fifth root of 16. We'll first combine the two cube roots, then express both factors with a common index of 15, multiply inside a single 15th root, and finish. Write the expression. Combine the cube roots. Cube root of 2 times cube root of 4 equals cube root of 8. Use the property. Fifth root of a product equals product of fifth roots. Convert each factor to a 15th root using the least common multiple of 3 and 5. Multiply inside one 15th root and rewrite powers of 2. The 15th root of 2 to the 15th equals 2. Display the root power property we will use. Step 1. Match indices by multiplying the index and the power inside the root. Step 2. Rewrite both radicals with a common index of 15. Step 3. Since the indices match, combine the quotient as a single 15th root. Step 4. Add the exponents inside. Step 5. The 15th root of the quantity to the 15th power equals the base. Example 2. Now simplify the product. The 4th root of -2 cubed times the 8th root of -2 squared. Again, we will use the root power property. Step 1. Convert the first root so that its index becomes 8 by squaring the inside. Step 2. Simplify the first inside power. Step 3. Combine the two 8th roots as 1. Step 4. Add the exponents and observe that the base to an even power is positive. Finally, the 8th root of 2 to the 8th equals 2. In this lesson, we will multiply radicals by converting them to a common index using the least common multiple. We'll solve two problems step by step, matching an algorithmic structure: convert, combine, and simplify. First, the key rule. The product of radicals can be rewritten by converting each to an index equal to the product of the original indices. I will display the rule on the screen before we apply it. Example 1. We simplify the expression. Cube root of 7 times 4th root of 7 times square root of 7. Step 1. Write it clearly. Step 2. Find the least common multiple of 3, 4, and 2, which is 12. Convert each radical to a 12th root. Combine exponents under a single 12th root. Finally, split perfect 12th powers to extract factors and simplify. Example 2. Simplify 2 times the cube root of -2 multiplied by 3 times the 4th root of -2 squared. Step 1. Separate coefficients and handle signs. The cube root of a negative is negative and -2 squared is 4. Combine numerical coefficients. Convert each radical to a 12th root using the least common multiple of 3 and 4. Combine the powers under one radical. Finally, reduce the index if possible. In this lesson, we simplify two radical products step by step using one powerful idea. Rewrite each root to a common index, then combine and simplify. Here are our two expressions. First, the cube root of 2 times the 5th root of 4 times the 4th root of 2. Second, 3 times the cube root of 4 times 4 times the 4th root of 2 radical 2. We'll solve each one carefully. The guiding rule we'll use is this: the product of different indexed radicals can be rewritten with a common index. Multiplying a mth root of a and a nth root of b equals the m nth root of a to the n times b to the m. In practice, we prefer using the least common multiple of the indices, so everything fits into one clean radical. Example 1. We take the least common multiple of the indices 3, 5, and 4. That least common multiple is 60. Now, rewrite each radical as a 60th root. The cube root of 2 equals the 60th root of 2 to the 20th. The 5th root of 4 equals the 60th root of 4 to the 12th. The 4th root of 2 equals the 60th root of 2 to the 15th. Now, multiply inside a single 60th root. Now convert 4 to 2 squared. 4 to the 12th is 2 to the 24. Combine the exponents on base 2. 20 plus 24 plus 15 equals 59. The simplified result is the 60th root of 2 to the 59th. In this lesson, we will simplify two radical expressions using a clean, least common index strategy. We'll follow the exact algorithm. Match indices by the least common multiple, combine factors, pull perfect powers out, and when necessary, rewrite with a common index to divide radicals. Problem A. We want to simplify the expression with mixed indices. We'll first match indices in the numerator by the least common multiple of 3 and 5, which is 15. Then convert cube root of a cubed to 15th root of a to the 15, and 5th root of a cubed to 15th root of a to the 9. Multiply them inside a single 15th root if desired. In the denominator, we have 7th root of a cubed divided by 21st root of a squared. We'll rewrite both as 21st roots, then combine in one radical. That becomes the 21st root of a to the 7, which is the cube root of a. Next, from the numerator, 15th root of a to the 15 is exactly, assuming a is non-negative. Finally, we need a common index to divide radicals. We'll rewrite the cube root of a as the 15th root of a to the 5. Now divide inside one 15th root to finish. So the simplified result for problem A is a times the 15th root of a to the 4. Equivalently, a to the 19/15. Problem B, we will simplify the product of a cube root and a square root that both contain -2 to the 3rd power. We will work over the real numbers. Match indices using the least common multiple of 3 and 2, which is 6. Convert each factor to a 6th root, combine under 1/6 root, and simplify by pulling out perfect 6th powers. Since the remaining radical has even index and a negative radicand, the value is not real. Final results. Problem A simplifies to a times the 15th root of a to the 4. Problem B has no real value because an even index radical of a negative number is not defined over the real numbers. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.